The normal distribution is a continuous distribution. That means your data values are not countable. Your normal distribution is mound shape. Looks like that. And it's symmetrical about the mean, and the mean and the median are equal. The distribution has an infinite range, and 6 standard deviations approximate that range. The mean equals the median. Now, we are not ever going to use this formula, but you know how we looked at the binomial tables, how they were calculated? Well, this is how the normal distribution table, the standardized normal distribution table, that's the formula that is used. And we won't ever do that, but I wanted you to have some appreciation for it. Now, before you can use value, your x is the probability that you're trying to find, and that's a real world x. Before we can use the table, we have to change that to number of standard deviations. And the way we do that is through this z transformation formula. So z is x minus mu divided by sigma, and mu and sigma will be given. Once you transform or standardize your x value into a z, the mean is always 0 and standard deviation's 1. The mean is 0 and the standard deviation's 1. And you will put your z value, your calculated z value, will be on this horizontal axis. But you know it's standardized because the mean will be 0 and the standard deviation will be 1. Now, let's just look at the table for a minute. The normal distribution table. You have to standardize your... All right, so this is the table. You will have calculated your z, and your z's, the first 2 digits of your z, will be found in this first column. And the number that's in the hundredth place, you know, if you've got a z, x dot xx, you'll always round these to 2 decimals. This is the 100th digit, and that's going across this top row. So let's say, and plus when you use a normal distribution table, always look at the interpretation of that numbers. These numbers, any number in here, will represent the probability between 0 and that z that you look up. So if I'm looking up, let me draw a picture. Let's say I want to know the probability between 0 and 1.28. You first look down that first column for 1.2, and that will put you here. And then you go across the row at the top, and you're going to look for 0.08. Because if you add these two numbers together, you get 1.28. So let's look to see where they intersect. 1.28 will be right there. And that would be the area underneath the curve, or the probability between 0 and 1.28. Now, something else I'd like to say to you. Your table, all your z's are positive. Look at these numbers across the first row. First column, top row. They're all positive in general. So if you've got a normal distribution, bell shape, mound shape, whatever, and you're looking at the probabilities underneath this curve, I'm talking about this curve here, if you sum all your probabilities, it would give you 1. By definition, it's symmetrical. That means you have 0.5 probabilities here and 0.5 probability there. That's all the area. There is 0.5. All the area over here is 0.5. If I had another curve, and let's say I want to find all of this area. Okay? That area right there, is actually the same area as this here. Now, your mean is 0 once you standardized your variable. That means any number to the right of 0, it's going to be a positive z-value. Any will be a negative z-value. Now, if you go back and look, but if I'm trying to find this area here, I look up the positive value of that z, and that will give me that area. Because if I look up this number here, it'll give me this area right there. But I'm looking for the yellow part. So how much area is between here and here? Or down here? It's 0.5. So what you do is use your table, take the z, take the positive value of it, look up that number, and it's going to give you the probability for this, which is the same thing as a probability for that. But if you want to find what's in the tail, you're going to say 0.5 minus that probability. Okay, and we'll do some definition. We'll do several examples in the next video. Let me see if I can do another quick example. I'm going to make this one easy. If I'm trying to find this area here, my z will be negative. So what you will look up is the positive z-value. Same number as this, just opposite sign, positive. And it's going to give you this area here. Any number to the left